So at the geophysics section at DIAS, we work on problems associated with the Earth, overall Earth structure, how volcanoes work, how earthquakes work, and the coupling of the oceans to the solid Earth. What we have are clusters of stations along the west coast, and from those clusters of stations we're able to say what direction the ground vibrations are coming from. Imagine a cluster like this. It will hit, if the ground vibrations are coming this way, it'll hit this station first, this next, this next, this next, and then this next. So we're able to say, oh, that's coming from this direction. So we're able to look in 5-minute windows at where on the seafloor these pressurizations are the greatest and how they evolve in space and time using the ground vibration measurements on land. And essentially what that tells us is that tells us the parts of the seafloor that are most pressurized by the storms or the ocean wave activity that's generating this pressure on the seafloor. One of the aims of the study is to get baseline information on the seismicity or earthquakes that we have in the offshore region. We currently don't know the details of them, how big they are, how often they occur, so we're trying to understand how the systems work. The reason that's important is that earthquakes can trigger possible landslides if you have unstable slopes in the offshore area, and those landslides in turn can break cables and in a worst case scenario generate small local tsunamis. There's a growing interest in the study of what's called Earth system science. That's the coupling of the atmosphere with the ocean and the coupling of the ocean with the solid Earth, instead of looking at each of them individually, to look at how the whole system works. And Ireland is in an ideal geographical location for looking at the coupling between the ocean and the solid Earth.